So you're running microservices on Azure Kubernetes Service, or AKS, right? And if you are, you know just how fast things can get, well, chaotic. Today, we're going to talk about exactly how to tame that chaos. It's the one question that probably keeps architects and SREs up at night. Your application's deployed, all the dashboards are green, everything looks perfect, and then the calls start coming in. And the thing is, the failures are almost never simple, are they? They usually look a little something like this. First up, you get those dreaded intermittent 503s, the service unavailable errors. They just pop up out of nowhere, disappear, and then you and your team are stuck spending hours, maybe even days, chasing this ghost in the machine that you can never seem to replicate on demand. It's maddening. Or, hey, maybe it's a security headache. You're trying to enforce encryption between all your services, right? But doing it manually, service by service, it's just so inconsistent. And honestly, it leaves these dangerous gaps wide open for an attack. And then there's this one, which might be the most frustrating of all. You've got total blind spots. You literally can't see which service is calling which, how often it's happening, or why a request that should take 200 milliseconds suddenly took 2 seconds. You're flying blind. So, when you put all of those things together, this is what happens. Your once beautifully organized AKS cluster, it starts to feel like a complete black box. You know things are happening inside, but you've lost all the visibility. And maybe more importantly, you've lost control. Okay, let's just walk through a pretty standard setup, something you've probably built a dozen times. A request comes in through an API gateway. From there, it hits backend service A. Service A then needs to talk to backend service B, which in turn has to call out to some external API. I mean, it looks simple enough on a diagram, right? But in the real world, every single one of those arrows is a potential point of failure. And this is the feeling it creates. This is the voice of that senior engineer on your team who just wants to build cool features, but instead they're stuck troubleshooting some bizarre network-level problem without the right tools. It's just a massive drain on productivity and, frankly, on morale, too. Okay, so here's the crucial takeaway. That architecture we just looked at, it leads directly to these kinds of pains. Failures become incredibly hard to diagnose because you just don't know where the problem is. Security policies like MTLS, that's mutual TLS, where services have to prove their identity to each other before they can talk. Think of it like a secret handshake. Well, applying that consistently is a total nightmare. And trying to shift traffic for something like a canary release, super complex. There's just no single place to see what the heck is going on. But what if you could add a completely new layer to your stack? A layer designed specifically to manage all this communication chaos and to bring some order and control back to your system. Well, that's exactly where a service mesh comes into the picture. Now, a service mesh isn't something you bake into your application code. No, it's a separate, dedicated infrastructure layer. And honestly, the best way to think about it is as an intelligent air traffic control system for your entire application. It sits there managing the flow, the safety, and the reliability of every single request flying between your services. And this really illustrates the transformation. It's a night and day difference. You go from the chaos of manual configs and those scary blind spots to a world of deliberate control, a world where security and routing are handled by policy-based automation, and you get this beautiful unified telemetry across your entire app. Okay, so that's the theory. It sounds great, right? But let's get practical. Let's see how this actually plays out with some real-world incidents, ones that I'm willing to bet you've probably faced before. Ah, yes, incident number 1, the retry storm. We've all been there. It starts when a downstream service, let's say that external dependency from our diagram, it just slows down a little bit. But then the upstream services start retrying their requests aggressively. And before you know it, that small slowdown has snowballed into a full-blown, self-inflicted denial of service attack that you created yourself. So let's look at the difference. Without a service mesh like Istio, when that dependency slows down, what happens? Your clients just hammer it with retries. The result is a cascading failure that takes everything down. And the impact? A full-blown outage. Now, with Istio in the mix, you can define a really simple retry policy. You can say, hey, try twice, but use an exponential backoff. The result? Graceful degradation. The system remains stable, and your users, they might see a slight delay instead of a complete failure. Huge difference. All right, on to our second incident, the security gap. This one is super common. In our example architecture, maybe service A is talking to service B over plain, unencrypted text inside the cluster. You kind of just assume the internal network is safe. But really, that's a massive vulnerability. So the question is, how do you enforce encryption everywhere and do it automatically? Well, without Istio, the story is familiar. Some services might be using MTLS, but others aren't. It's all configured manually, maybe even in the application code itself, and it's so easy to miss one. And that leaves unencrypted traffic floating around inside your cluster. But with Istio, you can set a single policy. We're talking a simple little YAML file that just says require MTLS for all traffic. That's it. The mesh handles all the certificate rotation and enforcement for you automatically. The vulnerability is closed everywhere. And here's the best part, without a single line of code changing in your services. That is a game changer. So the benefits are pretty clear, right? But let's be real, a service mesh also adds its own layer of complexity. It's not a free lunch. The real question is, are you ready for it? Is your organization and your AKS environment at the point where it makes sense? Well, let's go through a quick 5-point checklist to help you figure that out. Okay, so we've boiled this whole decision down to 5 key indicators. Think of these as the signals that your operational complexity is hitting a tipping point. And here's the deal. If you find yourself nodding along to, say, 3 or more of these points, it is probably time to start seriously evaluating a service mesh. All right, here we go. Number 1, your microservice count is growing, and growing fast. What worked for 5 services just completely breaks down when you hit 50. Number 2, your team is spending way more time debugging weird network issues than actually building new features. Number 3, you've got a mandate for strict MTLS, but trying to do it manually is just failing. It's error-prone. Number 4, you can't answer simple questions about your service traffic without having to check 5 different dashboards. And finally, number 5, you really want to do more sophisticated releases like canary deployments, but you just don't have the granular traffic control to pull it off safely. And all of this really brings us to the final, most important question you should ask yourself. Is managing your services becoming harder than building them? When the complexity of managing the communication between your services starts to outweigh the complexity of the services themselves, well, that's your signal. That's the exact moment a service mesh goes from being a nice-to-have to being an absolute necessity for scaling with your sanity intact.